Um, Thanks for being able to be here, Nick. I would like to say a couple of things. First of all, I think we are extremely lucky to be in Europe, that we are incredibly supported. And I'm not saying this because we have our project officer. Well, I can... Oh, yeah, it's okay. We get the opportunity to really do things, and I think this is fantastic. It's helping us a hell of a lot. Secondly, yes, we are lucky that we are also in Flanders, where what we're doing has been pushed and is being helped by the Vlaamse Waterweg. But I hear that in Holland it's going forward as well. We know that the VNF is working on it. The CCNR, it's only the Germans which are lagging at the moment, but I'm sure there's a lot of opportunity. And then last but not least, we are in a crisis. We are in a climate crisis. We saw yesterday again that what is happening in the climate, and we need to do things. There's a need for a sense of urgency. And so whenever I hear people say it's not possible because we have to change regulations and we have got time and it's going to take 10 years, what I'm saying is we don't have 10 years. We have to go very quickly to change the way we operate. And inland waterways, and this is my last bit, is often seen as being a very sustainable mode of transport, but in reality, at the moment, with the old ships and all that, it isn't. And we need to do something about this. And it's more than just changing from stage 2 diesels to stage 5 diesels. We do have to do a lot more. Anyway, having said that, I hope nobody's cross for me saying this. We are part also from Autoship, as you know, of Autoship, which with Vidar, we're working on something I think which is going to be great. But we're also part of the Seamless project. This is going to be better? Hello, hello. Oh, this is it better. And the aim of, oh God, this is very strong, of Seamless is to develop and adapt missing building blocks and enables, I'm looking at the official text here, but definitely to have economically viable, cost-effective and resilient waterborne freight transport for short sea shipping, but also inland waterways. And the main enablers that we're looking at are autonomous sailing, safe, resilient, efficient, mainly environmental friendly operation. We want to shift from road to waterways. We do that with a fleet of autonomous cargo shuttles or cargo vessels. And of course, we have to work with automated and autonomous shoreside infrastructure to achieve this. The members, some of the usual suspects, so as our Greek friends, Timio Danaos et Dona Ferentes, as we all say. But we've got some really incredible people there, like TU Delft, Sintef, some fantastic companies like Kongsberg, Bureau Veritas. All of them are fantastic, and we're having a good start, I can tell you. So again, a large group. The overall concept, as you can see, it's just more than running with an autonomous vessel. It is combining from the ports, the short sea vessels coming in, what's happening in the ports, putting it on the vessels, moving it on. It's the physical internet, but it's also all the digital parts that needs to be done. So it's quite a hefty program, and but I think with the team that we have, we'll be able to reach that. There are obviously some synergies with existing projects. We've spoken this morning about Moses, Autoship, Aegis. So we are looking at what can we use from these other projects that we can combine to actually move ahead much faster. So it's not rehashing and redoing what has been done before. It is using that and using it as a building block for what we want to do. Work packages, redesigning the design of well, obviously the coordination, but redesign logistic processes, the autonomous port operations, green autonomous feeder vessels, and the physical realization of that. And that is then combined with a financial and economic analysis, a demonstrator and validation campaign, and then absolute real demonstration of vessels. And this is where we're going to go in a minute. There are a number of use cases. The demonstration cases, one is up north in the Scandinavian countries. That's done with Kongsberg. Then we've got the one in Central Europe, which I'm going to talk about in a minute. And of course, we look at being able to transfer those cases to other places. You've got the possibilities around Valencia, you've got the Adriatic, you've got the Donau River, and of course the UK run for, well, because of Brexit, we need to lower the cost to move goods to the UK. The use case I'm going to talk mainly about today is the Central European use case. Parts of the group, as you can see here, and I'm quite excited that Le Voie Navigable de France is part of it, because they have really started to move in the same vein. Obviously, we are Port of Antwerp, and then MacGregor for equipment, ESL, Duisport. Of course, why? We're moving goods all the way, the basic ways from Lille, Lens, all the way up, going all the way to Duisburg, and then going on to Dortmund. This has sense, why? Because all of these waterways are very similar. And it was also in the Middle Ages that because of these waterways, the region was one of the richest regions in the Middle Ages because of that. And this is what we're going to do, move containers from Lille to Ghent, from Ghent to Antwerp, cross over Nijmegen, and then go all the way to Duisburg, and then to Dortmund. So it looks very simple, and we're going to do this with a autonomous vessel, which I'm going to go about in a minute. Challenges, yes. We have to get Voie Navigable de France, the Vlaamse Waterweg, Rijkswaterstaat, and the CCNR agree that we can do it. So the whole regulatory side is there. And of course, we have the ports which have to be involved. Port of Lille-Dourges, Antwerp-Bruges, a terminal in Nijmegen, and the port of Duisburg. One of the reasons we need these people also is, you'll see, the energy that we're going to use. This is the barge that we're going to do, and that we have redesigned. This is a real barge. Design is finished, almost, and we are now started to discuss with shipyards to build this vessel. It's an 85-meter vessel. It's a class 4. It's got a capability of carrying 19 TEU or 40, 45-foot containers, pallet wide. Why? Because that's the competition with trucks. It is designed not to have any crew members on board during transit, which means it's got a mixture of autonomy, artificial intelligence, and remote control center. It's got 2 rudder propellers at the back and bow thrusters, so it's got dynamic positioning. And because we don't have any accommodation, we put the energy in containers on the back of the vessel. Makes life simple. We will be working with batteries. That's why we need the potential stops, Lille, Antwerp, Nijmegen, and Duisburg. And these batteries are switched. Hello? Oh, okay. Here you see it in the version with 20-foot containers. Here you have the 45-foot pallet-wide containers. Gross weight, 1,500 tons. So what are the challenges? Well, we're going to use existing waterways, some large, some smaller. We have some tidal waters on the Schelde. We obviously have streams, rivers. Think of the Leie and think of the also the Schelde, but also think of the Rhine, also the part in Holland. The handling in the port is going to be a challenge. We need to moor the vessel without people taking any mooring lines, so there will be magnetic or suction mooring systems. Loading, unloading. What is interesting, well, I'll come to that in a minute, on the loading, unloading. Interaction with the river information systems. So planning the trip, exchanging where we're going to go, and having information from the VTS, that's the Vessel Traffic Services, the communication, and of course the interaction with the infrastructure, which mainly are locks and bridges. As you've heard with the AutoShip, the trip around the test site has basically all those elements on the trip. So we're using information, well, know-how from AutoShip to be used also what we're going to do. Zero emission propulsion, we are on a climate issue. Because we have autonomous sailing, i.e. no crew on the vessel during transit, we create economic margin to pay for the more expensive non-fossil fuel propulsion systems. The main I would actually call it suspects for that are obviously batteries, or hydrogen-based systems, fuel cells or ICEs, or even methanol ICEs. Batteries are very interesting, not just because the way they are not emitting anything during transit, but we can reuse batteries that were, for example, used for buses, which after 3 years are no longer fit for being used for buses, but we can put them on the vessel because the energy demand curve is different than if you have it on buses. So we are recycling with this existing batteries. Then for the infrastructure, where will we load those batteries or the hydrogen? Will it be on the quayside or not? If you have switchable modular battery packs or hydrogen fuel cells, you can do that in different places, and therefore you don't need to be on the quayside. As I said, modular power packs as opposed to versus installed power. Another big one is the size. As said this morning, in shipping, the paradigm is the bigger the better, because I have economies of scale. This is not necessarily so. When you have a big ship, it takes a long time to load it. Often, if for example you have a ship going from Henk in Belgium to the port of Antwerp, and you have 300 TEU, you will be loading it for up to 15 hours. It only says 12 hours, and then you unload it for 15 hours. So a container you do transport for 120, 130 kilometers, instead of being 4 to 6 hours on the road, it's taking 2 or 3 days even to get them on destination. So you cannot compete with trucks, not just on price and emissions. There's also a time issue. You have to be time competitive. So if you want to do really modal shift, this is our position. This is hopefully what we can demonstrate, is that smaller vessels are in fact far more efficient than bigger vessels for getting the modal shift from the road to the waterways. Of course, because of the size, you have a different planning cycle. Terminal organization is different. You can have smaller terminals. The cranes can be smaller. The link in logistic chain is different. And of course, the energy needs are lower. The vessel we designed, the X-Barge, will have about 300 kilowatt hour per hour need of energy, which means that if we have 3 1.5 megawatt batteries, you can see that we can work quite easily 15 hours with a vessel. 15 hours at 12 kilometers, we can sail with batteries from Ghent to Lille. And then, of course, having redundancy. Having one big vessel or having 4 small vessels means that if one breaks down, you still have 75% of your cargo capacity. If in the Suez Canal they didn't admit those very big vessels, you would not have the same problem as they had with the Evergreen. On the handling, mooring, I give an example here of a mooring system we have put on the Zulu 4, which works, which is quite impressive, magnetic, but there could be suction. Cranes, one often is these big Gottwald cranes, which are beautiful machines, but I don't know if you've ever seen how they put a container on a vessel, how this sort of moves way up and down. So we say it's probably better to have smaller gantry cranes, which are much more controlled and could be fully automated far easily. And then for the shunting, going for these smaller straddle carriers, which can be electric and also fully autonomous. So all these things are on the program to be tested. So what are we trying to achieve? Yes, we will be aiming to shift freight to water because of sustainability. Another element also important in inland waterways is that most inland waterways do not work at night, except if you have a double crew, which is then more costly. So autonomous operation allows you 24/24 operations. This also means locks, bridges and all that. So it's going to be interesting. We spoke about size and redundancy of the chain. More attractive jobs. Everybody's been talking about this, so I won't go much further into this, but sitting in a vessel 2 weeks at a time or being able to have a more social job, and face it, probably safer job, it's probably better, and also more attractive to women. We've got Pathway to Zero, alternative propulsion, the need for the alternative energy infrastructure, where are you going to load the energy? And then last but not least, on the smart waterways, autonomous operation allows you, actually forces you to issue a sail plan. And if you have a sail plan and you communicate that with the VTS, then basically, if all the ships were to do it, manned or unmanned, the VTS could tell me on Thursday afternoon at 2 o'clock what would be the situation of vessels on the rivers. And I see there are some skeptic people looking at that, but I think it is possible. Anyway, that means that we need digital communication, continuous update, and of course waterway monitoring. So those are the things we're going to try to demonstrate with the X-Barge through the Seamless project in 24-25. Right. Thank you. Any questions?
No questions online?
Yes.
Yeah, you mentioned from the regulatory side some organizations which are which you need to have them available when you're trying to do your exercise or your demonstration. What do they have to do now?
In certain cases, you can already operate autonomously. We have to go through a certain procedure. But in certain countries, like in France, there is nothing regulatory-wise. So it's virgin territory. They are working on it. So that's one thing. So we need to get approval to get the vessel go without crew from Lille all the way to Dortmund. And we need to negotiate that. And we need to see what needs to be done. It's easy in Flanders, and it's, I think, going to be easy in Holland. It's going to be more difficult in France and in Germany.
And what's the step after your demonstration?
We have clients. This is not just a vessel which for my own fun and games that we are putting in. We have a real demand at the moment for up to 8 vessels to be operational in 25. I personally believe that, we had a discussion here earlier today, the gross majority of our inland waterway vessels are obsolete. To make them green is fairly impossible. So I think we need to build between 2,000 and 3,000 new vessels in the next 10 years. And I think this could be an incredible economic impetus for Europe. We don't need to build them in China. We could build them here. And if we are intelligent and produce these vessels in a structured, even with robots, in that sort of way, then, you know, keep them simple, then we should be able to do that. What you also see in the vessel, it has basically no extra equipment. The mooring systems are on the quay side. There's no crane on the vessel. I've learned that when you put something on the vessel, it breaks down. So you keep as much out of the vessel as possible. Make it simple, because you can repair a mooring system when it's on the quay side very easily. You have the technicians, you have the equipment, you have the accessibility. Also, a lot of these equipments on a vessel are not being used most of the time because the vessel is sailing. So we need to rethink a lot of things the way we operate. But I think if we were going to build a program, let's say on average 3.5 to 4 million for each vessel, 2,000 vessels, you can see what the economic impetus of the inland waterways can be for Europe. And this is exciting. That allows us to create jobs beyond what is happening today. It's not just a few diesel people in Werkendam, it's going to be people all over Europe that can do things. And I have a lot of respect for the people of Werkendam, and don't get me wrong. But we are on the cusp of doing, you know, people speak about Elon Musk and, you know, how this thing going to Mars, what it is giving as a result. The leverage of doing that in inland waterways is just as big. It's just amazing. And then you can export it. In the States, they're like working like in the 19th century. South America. Go to the Po in Italy. There's nothing happening on the Po. They've got a huge, beautiful canal, the port of Mantova, the Canal Bianco. This is not being used today. Yet all the food stuff they make around the Po Valley, you could actually bring all the way to Venice or to Trieste. So there's a lot of opportunity there. I know I'm an excited person on this, and once I'm going, don't stop me because I'm... But the opportunities are amazing. And as I said, we are extremely lucky that we are in Europe and we are supported by the European Commission on this. I will stop.
Nick, we have Manfred Weiner from the online audience who would like to take the floor briefly. Manfred, can you hear us?
That's not the issue, but can we hear him?
Yes, I think he can hear us. Manfred? Maybe.
Manfred?
There he is.
No, he's unmuted. That's the...
While you are looking for him, you touched upon something I wanted to ask anyway. If you would build those vessels in China compared to building them in Europe, what would be the price difference? This is an ask questions I ask on behalf of the waterborne community, which consists of shipyards and so on.
Okay, if you build one vessel, unique vessel, then you will be much cheaper to do it in China. What the hell?
Okay.
But if we were to have a standardized vessel and we build it with what I would call robotics, like you do cars, then I think there will be not that much difference.
Then you're talking about
Seri-
bigger lots,
Yes,
bigger batches.
we are when the designing of the X-barge is also being studied to be able to build it simply, quickly, in large series.
So the Mr. Ford theory of 1915.
Yes, or
You
the
can
Liberty
build-
ships of 1941.
Yeah. Right.
We are at war for climate reasons. People think, oh yes, climate. I mean, we had the report
Yeah.
yesterday. We are at war. We need to do something about it.
Did you find Manfred?
Yeah.
Manfred?
He's unmuted, so normally we should.
No,
have him.
no.
Yes.
Okay.
Yes, loud and
Ah,
clear.
okay, sorry. It's the button on the headphone. Thank you very much. Perhaps I may bring in two points we discussed in our field briefly before. First thing, the day tomorrow is about digitalization of the inland waterway transport.
Yes,
And
it
so
is, yeah.
normally it is necessary to have a lot of documents on board of the vessel, common transport documents, documents about the vessel, which might be checked by inspection bodies during the journey. So did you already elaborate anything when there is no one on board of the vessel who may hand out these documents? Is there a complete concept to have them all digital available in the office, in the back office? And the other point is, you already elaborated the point that the loading and unloading also should be performed automatically, but it is also a point where a good contact and a good communication between land and vessel normally is necessary. And did you, for this point, involve the organizations of the loaders and unloaders of the land facility in your project? Thank you.
Well, very quickly on the first one, yes, we need to digitalize documents flow. Even today, having on a ship the original ownership papers. I mean, obviously it is today, but in Belgium in the registry, all the documents are in PDF. So if they're there officially, so why do you need them still on the vessel? That's one reason. But you're right about the cargo. The cargo has to be followed, and all that. But don't forget, the vessel is in continuous communication, so you know where the vessel is, you know where the containers are. So all these things can be linked together. As for the handling of the ship in the port or in the terminal, we have the concept of load master, which is a function which doesn't exist today, which means that in each terminal or in each port, you have people that will take the vessel, receive the vessel, make sure that the mooring happens, will go on board to do visual check and things like that, and be involved in the unloading and the loading. These functions can be done either by people on the terminal. For example, in the port of Antwerp, you could have the people from Brabo, or in Holland, the Koperen Ploeg could do that. There are ports where they have interest to provide those services. Or there could be somebody from the shipping line, because there's so many ships coming one after the other, that they can fill in that function. So yes, there is still a physical need. Don't forget, putting X-barges, or the way we see it, there still be lots and lots of jobs, not only in the remote control center. There will be people that need to do the maintenance of the vessels when they are on the quayside. So lots of things need to happen, and we still need people, but in a safer and I think better way. Is that okay, Manfred?
Yes, thank you.
Manfred, on digitalization, I thought only in Germany there were still documents required, or am I wrong? No
Pardon?
joking. I was joking. FT should be a solution for that. If you really talk about the mandatory documents on board of a vessel, the solution would be FT. And if all goes to the plan, it will be fully operational 2025, I believe. But of course, if officer starts that ask for documents that are not really necessary, yeah, then we may have a problem.
And we won't have schnapps on board.
Ah, yeah, and the schnapps will also not be on board. Some people say here. There's a Elvina. You have a.
Just to comment on what you said regarding the EFTI regulation and so on, we will organize, I guess, in some days, 2 or 3 days. Oh, sorry, Thomas is not here. He's leading this part. We will organize a workshop regarding EFTI regulation in waterway transport and so on. So I think if you want to have more information and background, we'll be happy to provide you some information.
Elvina is talking now on behalf of European Technology Platform, ETP Alice. So if you look on the website there, you can find the invitation and the dates on FT, right?
Yes, but I will present myself afterwards
Oh, yeah, you will
during the
present,
quiz salon.
Any more questions on seamless?
There is one from Gerd Daimel more specifically. I mean, I don't know if it has been covered or answered already, but it goes like this. What about the insurance questions in cases of accidents where autonomous transports are involved? Is this already in discussion?
We work with the remote control center, and one of the reasons is insurance. So ultimately, a person can still take over control of the vessel, and that is requested by the insurance companies. The advantage of having nobody on the vessel is that one of the most expensive risks, i.e. human life, is not on the vessel. So the cost is lower, but we still need to do it. And I think it's good.
Thank you.
Don't forget, the main point is no crew on the vessel during transit. That's where the economic leverage creates that we need. So, for example, the CFAR solution is a solution which can also work, but it's only navigational. So we need to do all the systems of the vessel need to be organized so that we don't need people, which means redundancy, etc., etc., etc.
Anything else? So this is the end of the. Not the end. So here the presentation regarding autonomous sailing stop.